Hi, Ian Campbell here from OnScale. I'm going to show you how you can use OnScale's cloud HPC platform to quickly optimize a complicated device like a SAW filter for RF front ends. In this study, we are going to start with a SAW filter of fixed size, fixed length, fixed width, and with a fixed number of interdigitated fingers. We want to know what metallization pattern and what metallization thickness yields optimal performance for this design. Our approach is to vary the metallization ratio, or the ratio of metallization on the top layer to die area, from a ratio of 40:60 to a ratio of 60:40 in 20 steps. Meanwhile, we are also going to vary the metal thickness from 180 nanometers to 220 nanometers in 20 steps. Now, this study would ordinarily require 400 discrete simulations, a daunting task for legacy CAE systems and legacy HPC hardware. But thankfully, we have access to the OnScale Cloud HPC platform, so we can run all 400 simulations in parallel and get results back nearly instantaneously. I'm going to start by opening up the OnScale GUI and choosing a parametric deck which already has parameters specified in our symbol language. In the interest of time for this demo, we will simplify the model by simulating a 2D cross-section of our 3D design, but full 3D optimization studies are just as easy to execute in OnScale. Next, I'm going to configure a new cloud job. I'm going to give my job a name and select the parametric deck as my input deck. I'm going to add the parameters that I would like to sweep, in this case metallization ratio and metallization thickness. I'm going to configure a cloud run to run 400 simulations simultaneously. After we get our results back, we'll have a look at the optimization response surfaces and select a few candidates to simulate with full 3D to observe mode shapes and other important behavior that only becomes apparent in full 3D simulations. Each of our 2D cross-section simulations took around 2 minutes to execute. So if we had executed all 400 serially, it would have taken over 13 hours to complete. But since we executed the sims in parallel on the OnScale Cloud HPC platform, we got the results of our entire study back in just 2 minutes. Our full 3D piezoelectric multiphysics simulation with nearly 5 million degrees of freedom runs in less than half a day. The results of this simulation provide a wealth of engineering insights into surface acoustic wave behavior, wave interactions at physical boundaries, and sources of spurs. Thank you for watching this demonstration of OnScale's Cloud HPC platform. Just imagine what you could do with limitless HPC resources. For more information, contact info@onscale.com.